Hi, I'm Liam, and this is my I2C data logger project. In front of me you can see the fully soldered version in a 3D printed case, and if I plug it in, it will start working. So as soon as I plug it in, you can see that some lights turn on. Firstly, this green light just shows that the power's on. This yellow light shows the indication of the square wave from the DS1307, and this red light will turn on when the sketch is finished, which is in 24 hours, so we won't see that. This display over here doesn't turn on because actually this is currently in a while loop, which is checking the state of this switch, because the circuit doesn't actually start until you flip this switch. And now you see that this display turns on and it shows the current temperature. This display can also be edited by now flipping the switch again, and it should turn to the Fahrenheit temperature now. It was Celsius. It's worth noting that this OLED display over here is working without the use of any libraries besides wire.h. So now we can go ahead and run the processing sketch. And as you can see, it opens up a pretty simple graph. So there we go, the sketch is done running, and what I found pretty interesting is the two bars, and I'm guessing what this means is that I don't have a very stable temperature inside my house, and the real temperature is somewhere in between these two, and the temperature sensor has to kind of choose one of them. And also what you can see is that for a 6-hour period, my house is cooled during the night. So of course, to make the data logger possible, the I2C communication protocol is used. And the I2C communication protocol is a communication protocol that has two communication lines, SDA and SCL. And with I2C, there can be up to 128 devices for one controller. So to do this project, I of course used the wire.h library. However, this library, while being really easy to use, hides a bit of what's going on behind the scenes. So to supplement that, I'm going to show the timing for writing to EEPROM using only the SDA and SCL lines. So to start out with all wire transmissions, the SDA line is pulled low while the SCL line is still high. Just like that. So the SCL line will follow and will be pulled low, but now all devices on the bus know that transmission is happening. They now all listen for their address, and the address of the EEPROM that we're writing to is 101. 0000, so I'll go ahead and write that down. So now the controller has transmitted the address of the device that it wants to talk to, and it then has to say whether or not it wants to read or write, and to do that it sends the read/write bit. In the case of I2C, a 1 denotes that the controller wants to read from the device, and a 0 denotes that the controller wants to write to the device. So here we want to write, so we keep SDA low while SCL pulses. So we've now said that we want to write to this EEPROM. Now what we have to do is we have to wait for the acknowledgement or ACK from the EEPROM. And what this is the EEPROM will pull the SDA line low in acknowledgement that it has heard its request. So I'll go ahead and write that down. So the EEPROM has now sent its acknowledgement, and now it is time for the device to send the controller its data that it wants to. And in this case, with the EEPROM, we have to send the high byte of the address in memory and then the low byte of the address in memory that we want to edit. In this case, we're going to edit address 0 in EEPROM, which is pretty simple. So this transmission in blue essentially just sends a byte containing all zeros over to the device, and since we want to write to address 0, the high byte and low byte will both be the same. So we can assume that we'll have two identical 0 bytes like this. So after the address bytes have both been sent, it's now time to write that data that we want to write to EEPROM. Now, let's say that we want to write all ones to EEPROM. I'll go ahead and write that down. So we've now written 8 ones to the EEPROM, and the EEPROM is now going to store these 8 ones in address 0 of memory. So we're done with the transmission, and to end the transmission, what we do is we raise the clock line, and while the clock line is high, like this, we also then raise SDL line, and this signals that we are done with transmission. So yeah, that's it. That's how we write to EEPROM using only the SDA and SCL lines.